So let's understand, why do we need to learn data science? Well, very simply, the reason one is data will help you guide your product intuition. So product intuition will only take you so far. I mean, you can make your judgments and you can from your gut feel or whatever, but data literacy will help you get there faster and in a much more better, much more confident way, because data will help you guide in the right direction, right? And that is why you should definitely invest some time in understanding data science. Then the second reason is data guided product roadmap decisions will make you much more confident, comfortable with where you're headed. So product managers may think that unsolicited customer feedback only helps them to understand the vocal minority, the customers who voluntarily share their thoughts and ideas. However, carefully collected feedback combined with other data provides an objective look at every customer, making it an excellent way to learn more about who your customers actually are and how they are using your product. Knowledge is power, right? Customer feedback is fuel for ideas. Customer data is fuel for decisions, right? I'll just repeat that. Customer feedback is fuel for ideas. They will help you come up with better and better ideas. But customer data is fuel for decisions, and that's why you pick up Amazon, you pick up Facebook, you pick up Google. Everybody's is struggling and running head over heels to figure out how to collect more and more customer data, right? So product managers can make more well-rounded product roadmaps by relying on a combination of feedback and the data. If you have both the things, then you can actually make much more solid and more likely to be successful product roadmap decisions, right? Because customer feedback is fuel for ideas while data is fuel for decisions. So you'll get both the if you get both feedback as well as data, you are in a um much more uh, likely to win situation. For example, when deciding between updating an old feature or adding a new one based on several customer suggestions, you can look at the lifetime value of the customers who have requested the update and the lifetime value of customers who have asked for a new feature to determine which initiative would be most valuable to a company. Later, whether you decide to update the feature or to implement a new one, you will be able to monitor its usage and impact on customers and determine whether it was successful. Number three, I would say it is simple. Nowadays, it is so much more easier to actually do data science or to gather to collect insights from data. So many tools are available. So not being a math person or a data scientist is no longer a valid excuse to diss data. There's not much actual math involved in data-driven product management, as the vast majority of tools out there right now come equipped with analytics packages that collect and present data in a very clear format. Thanks to this powerful analytics tool, you do not need to be a data scientist to collect and analyze data anymore. And according to a piece published by Harvard Business Review, you don't even have to be a math person to make smart data driven decisions. The HBR article suggests anyone without a basic understanding of statistics take a refresher, while noting that that said refresher does not mean going back to school. And so Nate Silver, who was the author of that article, he said, take a hands-on approach to learning about data. Getting your hands dirty with a data set is, I think, far and away better than spending too much time doing reading and so forth. Okay. So I remember I would like to quote. So in my last job at Oyo Rooms, I worked on two or three special projects where there was a ton of data and we had existing product which was not performing that very well, and I was tasked with understanding what is the problem and trying to fix that problem. I had no formal training in data science, and it was left upon me to figure out how to solve the problem. And I was actually seriously amazed by the quality of products available, right from Click to Tableau to MySQL in general, uh, to do quick analytics, to collect, query the data, and to make quick decisions. Within 1 week, I was able to move. I was able to work with few GBs of data and I was able to come up with insights which then helped us turn around the product and take it to the next level. So I'll strongly recommend that get your hands dirty. Okay, that's the best way to actually learn and get comfortable with data. And even if you prefer to take the textbook approach to data, an abundance of resources have emerged alongside the recent surge in data companies. So people with little to no experience um, can learn how to collect, interpret, and apply data. Right. So there's a very good article which I have linked in the speaker notes. I'll suggest please go through that. Right. Or if you prefer to see the big pictures first, big data fundamentals courses are offered at online education sites like Udemy, Cornell, and Coursera. I'll suggest that go through a refresher course. It will not take too much time, but the benefit is going to be long lasting. Right. And the end of the day, the my learning when I spent 3 months working on hardcore data science problems as a product manager on three different products where we had like few hundreds of GBs of data. My simple realization was that the only thing that matters is what kind of questions are you asking. Are you asking the right questions or not? If you're simply playing around with data, there is no end to that. But if you have the right questions, then you get the right answers. Else otherwise everything is gravy. So how do you ask the right questions of data from data, and how do you train yourself, right? So in the 2013 article, Keep Up With Your Quants, which is very good article, strongly recommend it. It's linked in the slide as well as in speaker notes. Thomas Davenport lists 6 questions that managers should ask to push back on their analysts' conclusions. Okay, what was the source of your data? The source of the data should be trustworthy. How well do the sample data represent the population? Right? Did you experiment, or did you look at the right data in the right place, or you were looking for the right data in the wrong place? Does your data distribution or the sample size include outliers? How did they affect the results? Right? Did you just looked at all the favorable results? Right? For example, all the 10-year to 13-year old who like Disney, uh, I think it will be overly positive an answer, right? But did you also include any outliers? So were there people uh, uh, who don't like Disney, or they found it very boring? You need to include the outliers to figure out whether they affect the results and how badly they affect the results, right? What assumptions are behind your analysis? There are always assumptions. Okay, people may say no, there were no assumptions. This is pure data, and this is the pattern is visible. No, there are always assumptions, right? And there might be certain conditions which may render your assumptions and your model completely invalid. Why did you decide on that particular analytical approach? What alternatives did you consider? And finally, how likely is it that the independent variables are actually causing the changes in the dependent variable? There might be other analysis establishing causality more clearly. Causality means the causes, right? So this article is a strong recommendation to read. The article offers a primer on how to frame data questions as well. And for a shorter walkthrough on how to think like a data scientist, there's another post which I've added in the speaker note. I'll strongly recommend that you read that. Uh, this particular article talks about how to apply a very basic statistical reasoning to the everyday example of meetings. Okay, it's a fantastic article. I'll suggest that you strongly read it. So to conclude, honestly, data science is very vast topic, and it's like people do PhD in it, right? So it's a separate topic altogether. My attempt here is to help you understand data science, what are the different nitty gritties of it, and give you a very good overview and corresponding reading material where you can go deeper wherever it is needed. That's it for now. See you in the next one.